Okay, is that all functioning properly?
Yeah.
Good. All right, so let's dive into this. So these are my co-authors, and I'll just mention that Ken Richmond was a fellow philosophy major with me as an undergraduate at Haverford College. And Elizabeth Kensinger, I actually met. I was 30 years old and finishing my residency, starting my postdoc with Dan Schachter. And she was 20 years old, a Harvard undergraduate doing her senior thesis with Dan Schachter. And she taught me how to do my first experimental psychology experiment. So we've had a long, productive collaboration with both of them. So, when we think about consciousness, obviously, some important questions to consider are, why did it develop? What does it do? What is it good for? And, some of the things that I've been wondering for a long time is like, why is consciousness difficult to control? When Nico and I were talking, we discovered we both spend some time practicing mindfulness. And it's like, it's hard, right? Any of you who have done this, it's like, it's hard to control your thoughts. And that's just I think it's just like a weird thing. Like, why is it hard to control our thoughts? I think it's one of the questions that needs to be answered. And in addition to controlling our thoughts, I think most of us, I will say, have difficulties controlling our actions, at least under some circumstances. I mean, if our actions are under our conscious control, then why is it that like millions of Americans have trouble, eating a healthy diet, maintaining a healthy body weight? Like another question that should be answered. And then there's some interesting sort of activities. It's like, can you drive or do other complicated types of activities without conscious awareness? Are things like this possible? Are animals conscious? And if they are, which animals are conscious? And are there developmental, neurologic, psychiatric disorders of consciousness? What about those? And I think most of us would agree that consciousness, in William James's words, feels sort of like a continuous stream. But we know that the brain is actually processing information sort of massively in parallel. And so the question is like, well, does consciousness sort of flow linearly with time, with reality? And, the answer from postdictive effects is that no, it doesn't always flow linearly with time. And the whole idea, the fundamental idea of a postdictive effect is that a later stimulus can affect the perception of an earlier stimulus, right? So this is sort of a strange thing. And William James uses the example that's actually a translation from neurologist Exner, and says, when you're deeply absorbed, you may not hear the clock strike, whatever the hour it is, but then your attention may awake after the striking has ceased, and you can count off the strokes. And so the sort of mystery there is like, well, were you consciously perceiving the clock striking or not? And I think in today's society, we don't listen to clocks striking that often, but we often are in a situation where the cocktail party effect may occur, where you're in another conversation, but you hear your name mentioned, and somehow you can perceive the earlier part of that sentence that included your name. How is that possible? And then we can get into some things that have been studied experimentally. So if a red disk is presented for 20 milliseconds, you can perceive the red disk, even though it's only presented for a very short amount of time. But if you have this red disk presented and then a green disk presented, you do not perceive a red disk followed by a green disk. Instead, you perceive a yellow disc. And then there's this experiment that Daniel Dennett spent a lot of time in consciousness trying to explain, which is that if you have, let's say in this example on the screen, a red dot in one place in space, let's say at the bottom, of the screen like this. And then you have a blue dot, you see the distance here and the time that, the red dot turns off, then the blue dot turns on at the top of the screen sometime later. If we perceive reality, we should see the red dot appear and disappear and the blue dot appear and disappear. But that's not actually what we perceive. We actually perceive the red dot moving from bottom to top, and in the middle of the movement, changing to blue. And the biggest mystery is, how can it change to blue in the middle before it's ended up in this location? Just makes no sense whatsoever in terms of at least a straightforward bottom-up view of perception. Then there's a few other things that have been called illusory rabbits. The cutaneous rabbit illusion is if you tap 5 times at the wrist, quickly followed by 3 times at the elbow and 2 times at the shoulder, instead of feeling individual taps, you actually feel a little creature running up your arm. Now, you have to not be looking at the taps, but you somehow feel like feet in between where the taps actually were. And then there are these very cool illusory audiovisual rabbits, where actually if you pair a tone with a flash of light, what happens is that if you do that a number of times so people are used to it, and then you skip the flash of light, but you still have the tone, people perceive the flash, even though it's not there. And if you do the same thing, but this time you have the flash without the tone, the flash is actually suppressed. So just completely wild events. And then we have things that are not exactly, they're not post-dictive per se, but we have these other sorts of paradigms like this, where you present a target, there's a variable, well, I should say sometimes the target is there, sometimes it's not. Then there's a variable delay, and you see this target is there for 16 milliseconds, so very fast. Variable delay, then there's a mask. And what's amazing when you put EEG electrodes on people's heads and you do event-related potentials, which we do in our lab, is you can actually find that the black, which represents mask only, is clearly distinguished from the brain from the seen versus not seen. So the brain, prior to around 270 milliseconds, it can tell whether or not it's mask only or there's a stimulus. But the person, number one, is reporting later. And some of the time, they can distinguish between whether the target is seen, and sometimes they can't. So how is it that like the brain can tell, even though the conscious awareness cannot? And then we get into Benjamin Libet's experiment. And I will tell you, Nico, I wanted to call him LeBay as well, but it turns out, so my boss, who is a neurologist, did his residency at UCSF. And Benjamin Libet was actually on the clinical service there. And my boss had no idea he was sort of doing this consciousness stuff. He was like helping them with like physiology and like in the pharmacology department or something like that. So that's how I know that Libet pronounced his name like that. So the bottom line for this experiment is that in this little cartoon, it's showing people pushing a button. In the classic experiment, Libet asked people to flex their wrist whenever they wanted to. And the thing that was particularly puzzling is that when the individuals marked on this special clock that they made the conscious decision to move, this readiness potential was already sort of preparing to move. And I should say there's other explanations like for this particular phenomenon, but what's nice about the theory that I'm about to share with you is it sort of explains the Libet experiment just as it is. Now, another experiment that Libet did is that he put sensors and stimulators on either the cortex of the brain where the finger area is, or he put the sensor on the finger area itself and recorded from the cortex. And so the findings of this are that, number one, you would expect that if you're stimulating the somatosensory area of the cortex over where the finger is directly, you would get the signal much faster than if you stimulated the index finger itself and had to wait for it to travel through all the peripheral nerves and the central nervous system pathways. But what he found, and this was in patients who were undergoing surgery and had their cortex exposed, what he found is that the sensations were delayed for both participants about 500 milliseconds, like a very long time when we're talking about neural transmissions. And what is so interesting is that the sensations were referred backwards in time. So although the sensations were delayed, people thought that they occurred at the proper time. Now, another thing that we know about consciousness is it's too slow for many activities that human beings engage in, including improvisational music, sports like hitting a fastball, as sort of shown in this diagram here, martial arts, and other sorts of things. You know, it's basically people have to be deciding to swing or not within, you know, a very few hundred milliseconds, way before there would be conscious perception and conscious desire to make a motor action. We also have a bunch of interesting patients that often have impaired conscious perception with intact action. And maybe the most famous cases of these are blind sight, where people say, you know, I can't see the stimulus in this part of my hemifield, you know, that had a stroke or a tumor resected or something like that. You say, well, that's fine. I know you can't see it, but just guess where you think the stimulus is. And people will be way above chance in their ability to guess. And then there's also these cases of these visual perceptive agnosias. And this is a patient here, D, who studied experimentally, had bilateral visual association area damage. And you ask her to match the card to the slot, and she's almost at chance compared to the controls. But then you say, don't worry about matching it, just put it through the slot. And what you find is that D is able to do it. So although she's not able to consciously decide what to do, if you tell her to just do it, she can do it. And you don't need actually to invoke patients with brain disorders to show this dissociation between impaired perception and intact action. If you give people these Titchener circles, I'm sure people are sort of familiar with the illusion that if you have the same size circle as in the top panel here, you put the small dots around it, the circle looks bigger. You put big dots around it, the circle looks smaller. But in this experiment, sometimes that was the case, and sometimes, you know, it wasn't the case, and the size of the circles were manipulated. And so what's interesting is that individuals would actually report that the circles were the same size or they were different sizes, and they would often be fooled by the illusion, the perceptual illusion, like we all are. But when you ask them to pick up the disc, their fingers were actually able to go to the right gauge, and they were not fooled. So somehow there's that dissociation between the conscious perception, which is wrong, errorful, and the accurate motor perception. So how is it that consciousness is contributing to evolutionary success? It's taking place often after the perception, decision, action have occurred. It's too slow to participate in many real-time events. From patients and healthy subjects, we know that judgments and actions can occur without accurate conscious perception. Mindfulness is hard, which again, I just find is just really odd. If consciousness sort of evolved to allow us to perform intentional action. So how does it do it? How does it contribute to evolutionary success? And this is when I can suggest, as Nico previewed, that we view consciousness as actually part of the explicit memory system. So episodic memory, as Endel Tulving so nicely described in the 1980s, is the set of processes that allow us to mentally time travel and re-experience a past moment in time. And so we argue that consciousness developed to allow the encoding and retrieval of episodic memory to take place. And maybe I should just sort of say that the reason that I think of this sort of insight or theory as sort of a potential paradigm shift is, in general, it's always thought, or many people thought that like consciousness was out there first, and then you have this memory system that evolved to help us remember what's in consciousness. But what we're saying is, it's the other way around. It's the consciousness is developing as part of the memory system. We argue that consciousness helps to bind the events, the elements of a memory together, including like sight, sounds, thoughts, feelings, and even for things like perception, color actually precedes motion in the visual system. So it would be like a very strange visual perception if somehow these aren't all bound together. Audition precedes vision. We all know how distracting it is if the soundtrack is off on a movie that we're watching. Well, that's how it is in our brain every day, and somehow we make these adjustments. Consciousness, we argue, provides a medium to replay memory traces, which we're going to get into in a minute as to why do you need this medium to replay memory traces. And then the other reason that I think it's so powerful to understand consciousness as part of explicit memory is we know that episodic memory developed not to remember past events verbatim, right? That's not what episodic memory developed for. Episodic memory developed to allow us to flexibly, creatively combine and rearrange memories of prior events in order to plan for the future. And we argue this is equally true for all explicit memory systems and for consciousness. And I would argue that this view of what consciousness is for is totally consistent with Anil Seth's idea of consciousness working as sort of a Bayesian inferential sort of calculator. And as Nico was saying, it's consistent with the ideas of Ledoux and Lau and their colleagues as well. Okay, so what do I mean it's true for all the explicit memory systems? I think your lab knows that you have episodic memory, which is memory for recent events, like what you had for dinner last night. Sensory memory is memory for the last half second to 2 seconds is when information is coming in and either can become part of working memory or forgotten. Working memory is, of course, the ability to keep information in our mind and manipulate it. And semantic memory is our ability to know facts, such as who Cleopatra is, that is not part of any episodic memory. So let me give an example as to how all of these work together. So we can have sensory memory. So let's say that we're walking across, let's say we're cutting across our neighbor's lawn and we hear dog barking, which is in our sensory memory. That gets into working memory that allows us to retrieve an episodic memory of when that very dog chased us off its property. And from this, it's not very difficult to imagine the future that that dog may chase us again. But the question is like, well, why is episodic memory important? Why can't you just sort of see the dog and let operant conditioning lead you to walk across the street? Well, we would argue that consciousness is necessary to remember the event with episodic memory. And why is remembering with episodic memory important? Well, the stimuli and setting may be similar enough for operant conditioning to trigger the response, but maybe it's not. So to just remind you, some of the implicit memory systems include, oops. Sorry, I think I froze there for a minute.
Good.
Okay, so some of the implicit memory systems include classical conditioning. This is like Pavlov's dog. Operant conditioning, when you're doing something for a reward or to avoid a punishment. And then, of course, there's procedural memory, doing things like, tying your shoes or riding a bicycle. Okay, now, why is remembering the event with episodic memory important? Well, sometimes the stimuli and setting are similar enough to trigger the operant conditioning response, but sometimes they're not. Or the other situation that can occur is maybe you do get the conditioned response, but the situation requires a different action. Now, how do you go from this conscious memory system to like all the other things that consciousness is involved with? Well, we argue that it's actually directly related to this ability to flexibly and creatively combine episodic and semantic memories and imagine the future. So, for example, let's say you visit the neighborhood of a cave sometime in the past, and you see some berries, and you pick these delicious berries, and it's great, and you have a good lunch. But then another time you go by that same cave, and you're chased by a bear. And so, of course, the problem solving comes in when you have these two episodic memories in mind, and you're able to basically think about what can you do in order to have one of those memories occur in the future and one of them not occur in the future. All right, so you might say, all right, so what? So, how does saying that consciousness evolved as part of the episodic memory system, how does this help us to understand consciousness, or for that matter, how does it help us understand any of this stuff? So what we argue is that if consciousness evolved as part of explicit memory, then there's no reason that consciousness needs to operate in real time, right? There's no reason, if consciousness is a system for memory encoding and retrieval, there's no reason that it cannot function properly with a small delay. So what we argue is that, we don't actually consciously perceive events in real time. We perceive the world as a memory. So our conscious perception is actually remembering a sensation. So we experience the world by remembering sensory memories. And of course, we're not just experiencing these sensory memories by themselves, because they're always a mashup, just like Nico was talking about the apple, between the bottom-up sensory processes that are seeing a red spherical object about, the size of a baseball, and top-down processes of episodic and semantic memory that help us to interpret what that object is. So we're always having our conscious perception being this sort of mashup. And once you think about this, then all of a sudden, there's no problem with all those order effects that we were talking about for consciousness to occur after perceptions, decisions, or actions. There's no problem with all these postdictive effects because we're simply remembering it. And what we perceive is that mashup. There's no problem with the brain detecting things separately from our conscious perception, because our conscious perception is a memory. There's no problem with delaying things in time and referring them backwards, because that's what memory does. Memory tells us when things occurred in time. And so it's sort of a built-in solution. Now, what about decisions and actions? Well, what we argue is that the you who decides and acts is actually unconscious. So your conscious decisions and conscious actions are actually memories of those unconscious decisions and actions. And I know this is probably particularly hard to, wrap your head around. But if you can, then there's no problem with the motor cortex firing first and then having the conscious decision to move. And there's no problem with all sorts of activities like improvisational music and, hitting baseballs and tennis balls and martial arts and all those things. It's just what we would expect. It's unconscious brain processes that are carrying out the actions, and then we consciously remember that we perform those actions. Now, we spent a lot of time in the paper, talking about the fact that just because we think it's unconscious brain processes that are driving our decisions and actions doesn't mean that our conscious mind cannot guide or influence our decisions and actions. And the literature that I lean to here that some people don't like, but these guys did get a Nobel Prize for this, is Kahneman and Tversky's System 1 and System 2. So in System 1 is this sort of fast, instinctual, unconscious system. And I should say that most of the criticisms of the System 1, System 2 is basically saying that System 1 is not one thing. It's a combination of things. And I agree with that too. It's operant conditioning, it's procedural memory, it's priming, it's a lot of different unconscious processes. But that doesn't lessen in any way, I think, the power of this explanatory model. And System 2 processing, this sort of slow, rational, conscious, deliberate system, we basically argue is this conscious memory system. And we argued that if you're doing something like, you're typing away at your computer, you're feeling a little bit thirsty, that by itself is a System 1 sort of signal to your brain. You may get up and walk to the kitchen and open the cabinet door and pour some water and have a drink and walk back to your computer. And I would argue that not only can you do that unconsciously, but you almost certainly do that unconsciously. It's like, do you think of exactly like how you lift up your feet? No, of course, you just walk using procedural memory. Do you think about how far you move your fingers up and down to grab the handle of the knob? No, of course not. You just grab it. It's like all this activity is going on unconsciously. And one of the ways that I think there's evidence for that is you can be in the middle of thinking about something, you can be in the middle of talking to somebody, and it's pretty rare that your thoughts will be interrupted. But of course, you could be in a situation like Katniss Everdeen, where you're thirsty and you're trying to get a glass of water, but to get the glass, you have to either go through a field of snakes, or you have to jump from lava rock to lava rock. And even once you make it, you have to contort your hand in a special way to get it through barbed wire. And that would be a situation that you're going to consciously, carefully think about, sort of what you're going to do at each step in order to get that glass of water. So basically, we argue that just like Kahneman and Tversky say that like 95% of the time, we're using our fast, instinctual, unconscious system to do most of our decisions and actions. But any time that we need to make a careful, consciously deliberate situation, that's when the system two, the conscious memory system, really comes into play when decisions and actions are difficult. So why is it that it feels like a continuous stream? We argue that the reason we experience events serially in time is because this is a property of our conscious memory system. Consciousness is in a timeline because it's part of memory, and memory is a timeline. And one of the other things I think is quite powerful is that there have been, examples, from at least as early as Plato's allegory of the cave, and up to and probably beyond, the Matrix movies, where I think that there's a feeling that we could be fooled by reality. It may be that we're really looking at shadows on a cave wall, or we're all in some sort of a simulation. And the question is, like, why should it be that way? And it's possible that what people are noticing is that, in fact, is that we don't experience reality directly, that we are a little bit removed from it. And why is this helpful? I think the reason it's helpful is that we have this conscious memory system that's able to sort of take the information and sort of move it around, just like we're a movie director moving around scenes on a storyboard. Now, I want to give you a analogy of a horse and a rider that explains how I think decisions and actions get made. And I think of the horse as our system one unconscious brain processes. And I think about the rider as our system two conscious mind. And the horse is in control of the moment-to-moment decisions. So, just like you don't need to tell a horse how to walk across a rocky field or jump over a small wall, like the horse knows how to do that. You don't need to tell it. And the human rider is mainly just sort of going along for the ride. But if you want that horse to go from Carson City to San Francisco, it's not going to get there on its own. You're going to need to be able to provide it with guidance. And that's what I think the system two conscious mind does. Now, how is it that the rider is able to do this? How can it get the horse all the way to San Francisco? Well, the rider has these cool sunglasses that can use sensory memory, can use episodic memory, can use semantic memory, can use working memory to flexibly, creatively imagine different possible future outcomes and act accordingly. So that's, how I think it works. And why is mindfulness hard? Because the images come from the horse. So that's one of the tricky things, but I think it explains why it's hard. So in other words, it is, our unconscious brain processes are in charge of what our conscious mind is seeing, just like it's sort of in charge of everything else. And, just like with other decisions and actions, we can still have an influence on what our conscious mind is going to be seeing, by, using an effort and sort of essentially convincing and cajoling, whatever that means in neural terms, to get our conscious mind to be paying attention to what we want it to. All right, so I want to switch gears and talk for a minute about the neuroanatomical correlates of consciousness. And, we argue that the conscious memory system supports both consciousness and all forms of explicit memory. And so you say, okay, well, that's no problem. So what are the neuroanatomical correlates of explicit memory? Well, for episodic memory, right, you're going to need, hippocampus, other medial temporal lobe structures. You're going to need Papes circuit. For semantic memory, the inferior lateral temporal cortex is particularly important. For working memory, frontal and parietal cortex and default mode network. Okay, well, that's good. But are there any other areas of the cortex that are important? And in fact, it was actually reading this book. It came out in 2020, which is a wonderful book, and I highly recommend it to people interested in the relationship between consciousness and memory. And it doesn't really talk about consciousness that much until the very end, and I think they got it somewhat wrong. But what this book taught me is that all cortical areas are important for explicit memory, and that every cortical region is contributing to memory, and we argue, and also a specific domain of conscious awareness. So, we don't think about sort of there being a single neural correlate of consciousness. We basically think there's going to be different neural correlates of consciousness for each aspect of consciousness. So visual areas are going to be important, going to have the occipital cortex as the key regions, auditory cortex for auditory consciousness, parietal cortex for awareness of space, somatosensory cortex for certain sensory domains. Motor cortex is going to be important for awareness of things like fine motor movements, et cetera, et cetera, et cetera. And we think that, each region of the cortex is autonomously conscious, and this sort of individual island of consciousness is not going to be dependent on any other cortical region. You have, to me, it's, sort of coming into this field in the last couple of years, it just seems almost comical that you have like half the consciousness researchers saying it's the frontal lobes, it's the front part of the brain. Then you have the other half of people saying, no, it's the back of the brain, it's the back of the brain, that's what's key. And it's like, come on, folks, it's not that complicated. It's all of it, it's the whole thing. And, some of this is influenced by, my experience of 25 years as a neurologist. There's no single cortical region, unilateral or bilateral, that renders individuals unconscious. I do think that there has to be a hub. There has to be something that has us being conscious of one thing at a time. I do think subcortical structures are the most likely candidates for this. And I think the intralaminar nuclei of the thalamus may be the hub. Now, why do I say that? It's because there are some patients that have found to have those areas damaged who are unconscious, and otherwise the rest of their brain seems intact. But it could be some other subcortical structure. Now, yeah.
Could you guys say something real quick? So do you think that the intralaminar nuclei are like generating consciousness? Like in what way is it a hub, you think? Like it could be just a background condion, of course. Like supporting
I think of it, yeah. So I think of it as like a relay switch. Like, those old-fashioned telephone connectors when they, pull out one connector and they punch it into another so you could connect people through a switchboard. Yeah. I think of it like it's just like a dumb sort of switchboard. That's how I think of it.
So it's like facilitating information exchange. Sorry, is the information actually going through the intralaminar nuclei, like the conscious information?
I don't think so. I think the intralaminar nuclei, if you like, sort of bars, global workspace theory, the intralaminar nuclei sort of shine the spotlight on the different actors on the stage.
That makes sense.
But the actors on the stage are the one that's actually generating the consciousness. So I think the cortical regions are what's doing it. And one of the reasons I think so is that the cortex is really complicated. It's got all these multiple layers in it. It's much more complicated than any of these subcortical type structures. And I don't see how a simple sort of on, off, or even like graded potential neuron is going to be generating consciousness. I think it's going to require some type of a circuit. And this is a leap of faith or a hypothesis, but I really think it's going to take cortex to have the requisite neuroanatomy to generate this sort of conscious subjective experience.
Yeah, because some people will claim that the thalamus is like the seat of conscious perception. I mean, that's like a pretty esoteric, right? But I agree with you.
No, I mean, I think it's a hypothesis that is a little bit hard to refute, but I just don't see how these simple subcortical nuclei that are basically just little switches can do it. I think it requires the sort of neuronal architecture of cortex.
Certainly necessary for wakefulness at the very least.
Exactly. It's like obviously it's important for maintaining consciousness. I just wanted to be clear.
Like a necessary. Same thing with the
and then the intralaminar nuclei are so tiny. Right. So even to say that is doing something, a lot of processing would be crazy.
So we get into animals, and I feel pretty confident that all mammals, they all have a hippocampus and cortex, and thus they have the requisite neuroanatomy for consciousness. So I feel very comfortable there. In the paper, as some of you may have noticed, we argued all vertebrates are conscious, and I think I probably still think that. I was speaking with Nicholas Humphrey at that Taormina conference, and he was trying to talk me out of anything below mammals. I don't know. He's a smart guy. I don't want to dismiss his insights lightly, but I'm still working on this one. But basically, the reason I think this is simply that if consciousness takes sort of, the neuroanatomy of it's the neuroanatomy of memory, so that's hippocampus and cortex, anything that has those things, I think, should be conscious. Now, I do want to say just very clearly, because I know, a lot of people argue that, cephalopods like octopuses are intelligent and may be conscious. And I just want to say, our theory doesn't say anything one way or another about any animal that doesn't have those structures. The only thing I might say is that if they have consciousness, it's going to be just different than the way that we vertebrates have consciousness. Now, what about neurologic disorders of consciousness? And this is where I think arguing that the cortex is conscious starts to really make sense, because we know that patients with epilepsy will often have an epileptic aura preceding a seizure. That's essentially an alteration of their consciousness in some way. And then, of course, what happens to people with epilepsy, which is a cortical disruption? They often become unconscious. Migrainous phenomena. I don't know if any of you have migraines and have the sort of classic migraines where you get a scintillating scotoma, which is what this artist is trying to represent here. There can be the positive phenomena like the flashing lights, and then there can be the negative phenomena where you can actually lose often half, sometimes more of your vision, and people can even have confusional migraines that they get confused. Strokes and other cortical lesions, I basically argue are, losing aspects of consciousness. I take care of patients with Alzheimer's and other dementia. I basically think we're watching them lose aspects of consciousness. And I think patients with delirium are basically awake but unconscious. I think there's psychiatric disorders of consciousness. I think the clearest situation, which William James talked about as well, are dissociative disorders, although he used a different word for them, including dissociative identity disorder, dissociative amnesia is maybe the prototypical case for this talk, and depersonalization, derealization disorder, and schizophrenia. I speculate, and there's some other people who speculated this as well, that really the hallucinations are sort of a disrupted, fragmented consciousness. And as I may have shared with some of you, my 23-year-old son has severe classic Cantor autism. And one of the things that helped me develop this theory is watching how he learns. And he learns like other kids with this severe classic autism. It's all through operant conditioning. That's how they teach them. They call it applied behavioral analysis therapy, but that's basically how he learns. Now, just a couple implications for everyday life, and then I'll close. I know I'm going on a little bit longer than I intended. Basically, I would argue that our decisions and actions are mostly unconscious. And even when we, I have sort of the morning routine here, which maybe you wouldn't argue with me, that when you shower and brush your teeth and get dressed, you're not necessarily conscious for all those things. But even when we're like in a meeting and coming up with a decision, I think we may be doing this really unconsciously, and we will then have a post hoc conscious explanation as to why we did this. Now, why should I think something like this? And it really begins with the work of Gazzaniga and his colleagues, over many, many years. This is the classic anecdotal patient experience where, they're taking a split brain patient who's had his corpus callosum section to prevent seizures traveling from one hemisphere to the other. They flash up a chicken foot to one half of the screen. The left hemisphere sees it, and the person points to the chicken. They flash up the snowy scene to the left visual field, goes to the nonverbal right hemisphere, and ask the person to point. And of course, they point with their left hand, controlled by the right hemisphere, to the shovel. So nothing mysterious so far. But then you ask this patient with the corpus callosum resected, why did you point to the shovel? And the response that the verbal left hemisphere, who did not see, this hemisphere did not see the snowy scene, says, well, you need the shovel to clean out the chicken coop. So it's a perfectly reasonable explanation, but it's wrong. It's the wrong explanation. And Nisbet and Wilson, way back in 1977, published a review showing all the time normal, healthy individuals are sometimes unaware of the existence of a stimulus that importantly influenced a response. They're unaware of the existence of the response, or they're unaware that the stimulus affected the response. So this actually happens all the time. And I think that, this whole memory theory of consciousness explains why people have difficulty controlling their behavior. I think it explains, if you ever have the experience that I sometimes do, that I'm like watching myself do something that I don't consciously want to do. And, I may tell myself, like, I don't want to be doing this. I should put down the spoon and stop eating the ice cream. I think it just totally explains it. Now, I feel it's necessary to say, although perhaps not to this audience, that, it's like we are both our conscious mind and our unconscious brain processes. It's not like we're only our conscious mind. In fact, we argue, and I talk about in the paper, that our personality, I think, is actually really our unconscious brain brain processes. But we're both. We're of course both. So it's not like there's some alien, controlling you. It's still you. It's just not. You're just not only your conscious mind. And then, of course, obviously, our conscious mind can influence decisions and actions. All we need to do is spend a couple of minutes, think about something carefully, and our conscious mind can influence, what we end up doing. But we just need to sort of have that little pause, think about something consciously. And I'll just give you a real life example of this for me. I have found that sometimes someone will email me something and I'll be like really irritated. And if I just respond very quickly without thinking about it, I may send off a nastier email that is really justified. All I need to do is spend a couple of minutes, step back, think about it a little bit, and then I can have a more rational, conscious response. And for things like dieting, I would say, the conscious mind has to be clever. You may need to use strategies and techniques, to try to do it. It's not just that having awareness that that's going on is going to fix all your problems, but I do think it's the first step. I think the first step is understanding, like, why is it that, we sometimes do things that we don't consciously want to do, and what are the ways to get about it. And I'll just close by talking about, I think, some of the most sort of impressive performances in, the realm of sports and music is, athletes and performers that are sort of using, taking advantage really of both their unconscious brain processes when they're sort of in the zone and allowing their unconscious brain to have sort of full reign, but also when they use their conscious mind to control it and to make differences. And I think a lot of art and inside a lot of creative processes are also coming about through this interplay of conscious and unconscious brain processes. So I will end it here, and I'd love to,